This is Mr. Downs here. This is part of a series of videos from the Winston Federation to help explain the way that we teach maths. This one is about addition. So in this video, I'll go through how we teach addition all the way from year 1 to year 6, going through the different methods and showing you how we would use them to calculate. The idea is that if you are a child at our school and you need a little bit of extra help, you might be able to look at the video and it might help you recap on some of the key methods. Or if you're a parent of a child at our school, you might be able to look at it, use that, understand it a little bit more, and be able to help your child with some of the work that they're doing. So I'll start with going through year 1. We'll go all the way through to year 6, and you can see how it progresses. Now, the methods should stay relatively similar all the way through, and that really helps our children understand what they're doing. So in year 1, we would start with adding one-digit numbers within 10. And we've got lots of different ways in which we would do that to get them used to seeing the calculation in different ways and how they might calculate in different ways. It really helps them understand number. So with one calculation, I've got 4 add 3 equals 7. There's lots of different ways that we would represent this. This might be with number shapes over here. So I've got a 4 and a 3, and then they'll be able to count that together and see it. Could be with a tens frame over here with counters. So you'd put down 4 red counters, 3 yellow ones, count them up to make 7. Could be with a part whole model up here, and that can be done with digits or with cubes. They can use manipulatives. So a part whole model, and we'll see this all the way through because the representations are very similar. This one is your whole. These two are the parts that go into it. So if I had a 4 and a 3, if I put them together, that would make the whole, and that would equal 7. We can also show them that with cubes, moving into what we would call a bar model. 4 and 3, and the total would be 7. Could look at number tracks and starting at 4, counting on 3 to make 7. Look at these basic calculations and show loads of different ranges of ways in which they can calculate it, so they understand that it's not just one process and there's different ways that they can see it. So as you or your child progresses through the school, so they're moving into year 1 and year 2, starting to look at adding 1 and 2 digit numbers to 20. And again, we've got similar calculations, similar ways of showing it in different representations. So I've got 8 add 7 equals 15 here. Again, we've got a part whole model, very similar to year 1. You add the 7 and the 8 together to make your whole, and that would be 15. Over here, you've got a bar model, you've got parts, you can have number shapes, and we can show different ways in which we can represent that calculation. You can do it with straws, so you'd have a bundle of straws that makes 10, and then individual ones to make 5. You've got your 15 there. We also show them different ways to use number lines to be able to support their calculations. They might start at 8, adding 2 more to get to the 10. How many more have they got left of their 7? 5 more to get to 15. So again, we're just extending the calculation, but we're using the same representations to do it. So as we're moving into year 2, we're starting to have more numbers, but we've got very, very similar methods to be able to calculate them. Again, we've got a part whole model over here. We've got a 16, and you can get 7, 6, and 3 to go into it. Over here, we've got our number shapes, and the children at this age would be really encouraged to use their number bonds. So in this calculation, you've got a 7 and a 3, and they would go together to make a 10. And then I've got my 6 to make 16. And we've got the same over here, where we're looking at more formalized calculations where they can do it a little bit more abstractly, so they wouldn't need to use as many pictures or manipulatives to be able to calculate it. They'd be able to look at the calculation, do a 7 and a 3 and make 10, and then you would add the 6 afterwards. Same again here, we've got our counters. You've got your 3 numbers. Here in this one, they've put the 3 together with the 7 to make a 10, and then they've got their 6. So we've got similar sorts of methods, similar representations, but the calculations just start to get a little bit trickier. So as we're moving into year 2 and 3, we're starting to use more abstract representations of that calculation. So over here, we've got a number line, for example, but we've removed the numbers off it, so they're making their jumps. So I'd start at 38, add my 2 to get to 40. How many more have I got left of my 5? I've got 3 left, and that'd make 43, and that's the calculation. 38 add 5. We've got our straws that they can use to make up that calculation. We can just be counting on along. Again, we've got a part whole model over here, and this is also where we start to introduce things like 100 squares, because they're counting digits to 100, and they can count it on and see the patterns that happen with that. So all this is building up to when we start to get them to look at representations in formal methods, and this is a much more abstract method. So in between years 2 and 3, if your child is ready for it in year 2, they'd start to be extended onto it towards the end of the year. But certainly in year 3, we'd be looking at these bigger calculations. So we've got two digit numbers to 100. We've got the same representations on here, similar ones that we've already seen. So we've got a part whole model over here, a 23 and a 38. They go together. Down here, we've got a bar model. They go together over there. Here, we've got a number line jumping. So we start at the 38. How much to get to the next part? The next 10, that's 40. How many have we got left? 21. That might be jumped in terms of a 20 and then a 1, or they might be able to just add that 21. Start to look at place value counters over here. I've got my 30, 3 10s, and 8 1s. And I've also got my 23, I've got 2 10s, and I've got my 3 1s. In this calculation, they've put together or enough ones to make a 10, moved it over into this column, and then you've got your answer. You've got 6 10s, and you've got 1 1 left over. Here we're starting to use some base 10, which we would have used already in the other year groups, but this is a representation of it. In this one, you've got cubes to represent 1. 10 of those cubes would make a stick, that's a 10. They would make a square after that, that's 100, and then a cube after that. We're starting to include up to 1,000. So in this one, they represent the calculation very similar to this one. Now, I'm just going to go through this calculation down here. This is the method that we would start to use at the end of year 2 to year 3. And it's a very similar method all the way through. So it doesn't really change. There's slight tweaks to it, but the method would remain the same. It means if a child goes to a different class, they know how to calculate, they know what they're doing, and they've got a good understanding. But we keep it very, very structured across, very consistent across the school, so it's much easier for the children. So I'll go through that calculation. I've got 38 add 23. So I'll start off by doing my 38, put my addition, and my 23. So they're lining those up in the columns underneath each other, making sure they put their addition sign because the subtraction calculation is very, very similar. And then at this stage as well, we're also expecting our children to put their place value headings because they really need to understand their place value. So this column is for 1s and this column is for 10s. We put that in there just like that. After that, they put a line underneath it. Now it's just a single line, nothing more than that, because it saves a bit of time, makes it easier for the children. And if they don't have a line here, it means they can run cumulative calculations that they'll need to do as they start to get further up the school. They can just start to add numbers underneath that as they go, or subtract them if they need to. So then we would go 8 1s, add 3 1s, that's 11 1s or 11. Your 10 would go into this column above the line, and the 1 would go down here to make 11. Now I'd move into my 10s column. I've got 3 10s, add 2 10s is 5 10s. I'd add that 1 10 to make 6 10s. That's 60, but we can just put it in there as 6 10s down there. And then child would be expected to just cross that one out. We've got our answer of 61. Now that method remains largely the same as we go through, but we'll see how it might slightly change. So as your child would then progress through the school, moving into year 3, again, you've got similar methods, but we're looking at adding numbers up to 3 digits. We've got our part whole model over here, representing that calculation in a different way. Just helps the child understand what a question is asking them to do, even if it's represented in all sorts of different ways. We've got our bar models over here, showing it in different ways. That can help them visualize the process. Again, we're looking over here in our base 10. We've got our 1s, our 10s, and then we're moving into hundreds over here. So it's just visualizing that calculation, and we can use place value counters to show it as well, just like we did in the year 2-3 crossover. Then we're also extending them into that former method. As you can see, it's exactly the same. You've had your 5, add your 4 ones equals 9. 6 tens, add 6 tens equals 12 tens. So here we get to a process that we call bridging, which we just showed in the last one. That 1 would go into this one because it's 100. And then we would add that column. So 200s, add 100, add that extra 100 makes 400, and then the child would just cross that out. So I'd have my answer of 429. Again, we need to make sure the child puts their place value headings at this stage because it really helps them understand what it's really worth. We ensure they put their calculation just here so they know that it's an addition, not a subtraction. And then we just put the 1 line there because it saves a bit of time and it helps them later on if they need to use it. As we're progressing through the score, again, we've got same methods, same different ways of visualizing it, but we're looking at adding numbers with up to 4 digits. So we've got our part whole model over here. We've got a bar model over here where they join together to make the whole. We are representing them with place value counters. So this calculation over here, I've got 1,000, which is there, 300s, which is there, 7 tens there, and 8 ones there. Underneath, I've got this number, 2,000s, 100, 4 tens, and I've got 8 ones. Now, what the child has done in this calculation is they've started off with the addition over here. They've found enough ones in there to be able to make a 10, and they've moved that over into this column. In this one, they found enough 10s to make 100, moved it into this column, and then all they need to do is add up how many are left over in there. So I've got 6 ones, which goes there. I've got 2 10s, which goes there. I've got 500s, which goes there. And I've got 3,000s, which goes there. And then it's the same process that's happened in this one, but with bigger representations of those numbers. Now, up here, we're all working towards this method. It's exactly the same as the one that you've seen previously. We've got our place value headings at the top, so they understand their place value. And then they've gone through the calculation. 8 add 8 equals 16. That 10's gone into that column. 7 add 4 add 1 equals 12. That 100's gone into that column. 3 add 1 equals 5. And then I've got my 1 and my 2 equals 3. And you can see those bridging digits have been crossed out so the child knows that they've used them. So as we move forward into year 5 and year 6, we are starting to change the method slightly, but only in the sense that we remove the place value headings. So we've got a larger calculation here, adding numbers with up to more than 4 digits. I've got our part whole model over here, same representation of it. They might be shown something like that they need to calculate. They can be shown it in a bar model and then they'll understand how to do that calculation. And then we can also, similar as we did lower down in the school, we can use place value counters to be able to visualize the calculation. All that leads together with them understanding how to be able to run a calculation just like this. And as you can see, the only difference that's happened here is when they get into year 5 and year 6, we're happy that they have mastered their understanding of place value. They know what their columns are worth, so we don't put them on there anymore. So calculation remains the same, just the 1 line again. We've got our addition just over here. 8 add 1 is 9, 2 add 3 is 5, 3 add 7 is 10. The 0 would go there, and the 1 would be bridged into this column. 4 add 1 equals 6. I would cross that digit out so I know I've used it. 0 add 6 is 6, and then 1 on its own would just equal 1, and then I've got my answer to my calculation. So it's exactly the same method all the way through. It only changes slightly, but it does help the child to be able to progress through the score if it stays the same. Now, here we're moving into year 5, which would also be in year 6. We're looking at adding with up to 3 decimal places. So in this calculation, the only part that really changes is the fact that we've got a decimal point in there. The calculation doesn't change. It just means we need to make sure we include that. And I'll just go through that calculation briefly as well, so we know what we're doing with that one. So still representing the same ways that we saw all the way from year one. So they've got a really good understanding of that. Our part whole model over there, my 2.41 and my 3.65 come together to make a number. It's the same with my bar model. They come together to make a different number. And we can still represent this with place value counters as well, to be able to help them understand how that works. Now, with a calculation like this one, I've got 3.65 add 2.41. So I would go on here, put my 3.65. I'll just make that decimal point a little bit clearer. And it's really important that the child puts that on the line and doesn't give it its own box. Now, that saves misconceptions later on. Like, for example, when we're multiplying and dividing by 10, 100, 1,000, they might use that as a column. It goes on the line and it never moves. We teach them that. So it's really important that they include that in there. I'll just check what the calculation was. It was 2.41. So I'll put that underneath 2.41. We're happy that our child understands their place value, so we don't put our column headings on at this point. They just need to include one line underneath, just there, because then they can do additional calculations underneath if they need to, and then they need to put that it is an addition calculation. So then I would do 5 add 1, 500s add 100s equals 600ths, but that would be 6. Over here, I've got 6/10 add 4/10 would be 10/10. I'd put my 0 there, and that 1 would be bridged into this column. And I've got 3 1s, 2 1s. Add the 1 would equal 6 1s. I'd make sure that gets crossed out, and then we need to remind the child to be able to put their decimal point there on the line. And that would be how that calculation would work. So that is our addition policy all the way through. From year 1 goes to year 5. It's exactly the same steps in year 6. You can see it's consistent all the way through. Very similar methods, but that is how we teach addition across the school. I hope that has been useful if you need to use it, and thank you very much for listening.